Hello everyone. Today we are going to discuss the seventh lecture of induction machine. In this lecture we will going to discuss the various methods of speed control, how we can control the speed of induction machine by various methods. First method by which we can control the speed of induction machine is by changing the applied voltage. We all know that the torque is directly proportional to the applied voltage. So by changing the supply voltage or applied voltage, we can change the torque speed characteristic, and consequently we can change the speed also. So we can see that for starting torque at lower voltage is lower. So if we see in the speed torque characteristics, so voltage values, if we reduces the voltage values, the voltage torque speed characteristic also changes. And for the lower value of voltage, the speed curve is also reduces, slope is reduces, and the starting torque value is also reduces. As we can see from here, voltage V3 is having low speed torque characteristic in comparison to that at voltage V1. So by reducing the supply voltage, the torque speed characteristic changes, and consequently we can get low torque at low value of supply voltage. So this is one of the method. The other method comes is rotor resistance control. I already discussed in last lectures that how we can effect of rotor resistance on the speed torque characteristic, and we discussed the starting method also. In the starting method we see that the slip at the maximum torque is depending on the rotor resistance. However, the maximum value of the torque is independent of the rotor resistance. So therefore, if we change the rotor resistance, then the slip torque characteristic changes, but the maximum torque remains the same. So this can be verified from this curve, that the maximum value of the torque remains the same. The maximum value of the torque remains the same, whereas by changing the rotor resistance value, the curve shifts. The curve is shifting, and the starting torque value is changing. The starting torque value is changed for every curve. Therefore, we can conclude that by changing the rotor resistance value, the torque speed characteristic is changing, and therefore we can control the speed. We can change the speed, and the maximum torque is remaining same. So this method is very much useful where we require maximum torque to be same. So this method is applicable to the machines where we want the maximum torque to be same. So this method has some disadvantages also. One of the disadvantage is that additional resistance is required to be put in the rotor circuit, and this called some heat and wastage of energy in the resistance, external resistance. So power dissipation resistance connected to the slip brushes should have good power dissipation capability. So this is one of the requirement of this method. And now the third method is cascade control. Suppose we connect two different induction machines having different number of poles and running at different frequency are coupled together. Then the frequency of both the machines is different, and number of poles should be different, so that we can have different speed at which both the machines can run. So we can see from this equation that let us have the rotor output of first machine. Rotor output of first machine connected to the stator of the second. Then the resultant stator MMF of the second machine may set up an air gap flux which rotates in the same direction of the rotor or opposes it. So there, if it is running in the same direction, then we can have this number of speed, and if it is running in opposite direction, then we will have different speed. So we can have different speeds by the connection of both the machines, how they are running and how their air gap fluxes are combining together. If it is in the same direction, then it is adding the number of poles. If it is in opposite direction, the number of poles is subtracted from each other. So we are possibly we can have two different speed at which this machine can run, possibly two different machines. Cascade control system is having the two types of different speeds available, and this is the equivalent circuit diagram for this machine. And now we can move forward and we can see the next method, that is pole changing method. We all know that the slip ns is formula of synchronous speed is slip frequency divided by the number of poles. So by changing the number of poles also we can have different synchronous speed, and consequently we can have the different rotor speed. First method we are discussing poles, and then we will find in the next method we will change the frequency also. So by changing the frequency also we can get the different synchronous speed and different rotor speed. In this method the number of poles arrangement can be varied, and the connections can be varied so that number of poles can be changed. So it can be seen from the figure that we are having different connections available for, so that we can have different number of poles, and if the pole can be changed, then we can have a different speed available. So here we can see by changing the terminal connections we can get either 2-pole or 4-pole field, and therefore the synchronous speed can be changed, and synchronous speed is having directly connection with the rotor speed. As the synchronous speed changes, the rotor speed also changes. So this is all about the speed control. Last method we are discussing here is stator frequency control. So as I told you that synchronous speed depends on the frequency also. So by changing the frequency we can change the speed of the induction machine. So let us see how it can be done. In order to reduce the speed, frequency has to be reduced. In order to reduce the speed, frequency has to be reduced. Now if the frequency is reduced, the voltage is kept constant, then what will happen? If the voltage is kept constant, uh, thereby requiring the amplitude of flux. If frequency is changing, voltage is kept fixed, then this flux will try to change. And when is frequency, suppose we are reducing the speed, so we are reducing the frequency, then to keep the voltage constant we require the flux to be increased, and this creates some problem, because if the flux is increased then machine will likely to enter into deep saturation, which should be avoided. So therefore the what last option remains is we have to maintain the voltage to frequency ratio. So voltage to frequency ratio, if it is maintained, so flux level can be maintained only by voltage keeping the constant voltage to frequency ratio. So in this method we can obtain the different starting torque and different speed curve by having maintaining the voltage frequency constant. So this curve is obtained by keeping the voltage to frequency ratio constant. We are having different torque speed characteristic here, and it can be easily seen that the maximum torque is remaining same also in this method, while the starting torque is changing. You can see from here starting torque is changing. So different frequencies we are having different curves, and So this is all about how we can change the speed, and this method is also having one of the advantage that maximum torque is same. So this is all about how we can change or vary the speed torque characteristic. So this is all about this lecture.